guys, I don't have a lot of time. I spent a little time making a practice review quiz. Hopefully you get to find this. I told you to watch me and follow me on Remind, so hopefully you got this. If you know somebody who's not on Remind, you might want to let them know. Of course, my computer's acting funky. So, if you like this, you know, you could always tell your parents, Mom, Mr. Krause is awesome. We should donate to his maybe GoFundMe page or whatever. Anyway, the document that I'm using right now is on my website, www.mrkrausemath.com. It's right on the home page. It'll say something like review and then a click for a link for the video. So if you want a copy of this and try it on your own first, go ahead, by all means. Pause this video, go watch it, mrkrausemath.com. Go look for the notes. It's right there, print it. It's only 2 pages. Maybe it's 3, I'm not sure. And then you can check it out. Okay, I'm going to go through this quick and dirty. This is going to be what's on the quiz tomorrow. If you don't know this, you might want to do a little review. And I did fix the links on my website for the videos. So it should be good. Odd functions. Odd function. The most basic odd function is a line. A line that has a negative slope goes down. So from left to right, because this is an odd function, it should be coming down. But because it's a 5th degree polynomial, it should have 4 extrema. A couple of mins, a couple of relative mins, a couple of maxes. So because it's got to come down, I'm going to start up here, and I'm just going to make some humps. Woo, 1, 2, 3, and 4. Notice when I'm done with 4 turns, or 4 mins and maxes, I'm going up and down. So this would be a 5th degree polynomial that has a negative coefficient. It doesn't matter that it's 3. I mean, as far as do you understand what the end behavior is going to do? Okay. This one here is a degree 4. Now the basic even function is a parabola. So if I take a look at a quick sketch of a parabola, if I take a quick sketch of a parabola, hopefully I'm going to be able to write soon. God, I'm going to kill this computer soon. Okay. Having major issues tonight, kids. Sorry about that. All right, you guys need to click on my ads so I can get some more links. Only if they make any sense. Only if they help. All right, so I got to erase that crap because that's just useless. So if I can take a quick sketch of what this thing looks like. Bam, bam. Even function. So that's a parabola that has a positive leading coefficient will be a parabola up. Now because this is a 4th degree polynomial, it should have 3 mins and maxes. Now it's pointing up. So what I got to do is start by pointing up, and then we're going to go up 1 turn, 2 turns, 3 turns, and up. Something like that. Now, even you get to pick. Even and positive. I could just do a parabola going up. Simple as that. Simple, simple, simple. All right. These ones are going to be a little complicated. These ones are very tricky. I'm hoping you're paying attention. So what I need to do is figure out what is the degree and what is the leading coefficient. The degree I'm looking for odd or even, and the coefficient I'm looking for positive or negative. So in this case, first, I'm going to talk about degree. Yes, I see a squared here. But if I realize that these are going to get multiplied, right? I'm going to do all this double distributing things, right? All this gets multiplied. Well, when I'm done, this these two multiplied together, I should be doing this. This and this multiplied together will actually give me, I don't even know what to say. This is just ridiculous. This will actually give me an x cubed. X squared and x will give me an x cubed. So my degree is 3. My leading coefficient is this thing right here. It's going to be negative. So negative 3. So it's odd. It's 3rd degree polynomial. That means it's going to be coming down because it's negative. And it's going to have 2 turns because it's odd. One goes up, one goes down, something to that effect. Now, my leading coefficient here is positive, and I've got an x times an x squared. So that means my degree is 4, and my leading coefficient is positive 1/2, which is just positive. So I need a 4th degree positive going, so once, twice, something to that effect. That's all there is to that. So just be careful with those. Write an equation of this function. So, first of all, what's the domain? Domain is negative infinity to positive infinity. Nobody has any problems with that anymore. Range is negative infinity to positive infinity. But if I had to write an equation for this function, I need these 3 roots. So my 3 roots are, now remember, we're going to write it like this. F of x is equal to, now my 3 roots are x equals negative 2, x equals 1, and x equals 3. So if you remember correctly, these came from parentheses. This came from x plus 2 times x minus 1 times x minus 3. But remember, that graph, it could also be for this function, which means my leading coefficient would be negative. Or it could be for this function. You know, who knows? So what I need to do is also include, right out here in front, a constant. Now I want to find out what that constant is. So what I'm going to do is I'm going to pick a nice point. This looks like a nice point right here. That point is 2, 3. This is my x value. This is my y value. And I'm going to plug this into this equation to see if I can find c. So 3, which is the y value, is equal to whatever this constant turns out to be. And we're going to plug in the 2 for x. So 2 plus 2 times 2 minus 1 times 2 minus 3. Well, this is 3 is equal to c 4 times 1 times negative 1. Okay, before I continue, I want to make sure I have my calculator up and running. So that's up and running. Let me just go back to my OneNote, if I can find where my mouse pointer is. Go back to OneNote. Okay, let me finish. Now I know it's not going to run well because my computer, now it's got that other one more application going, so that ought to kill things. So this is 3 equals c times negative 4. So I divide by negative 4, I divide by negative 4, and I get c equals negative 3/4. Well, that means that my function then is f of x equals negative 3 over 4 x plus 2 x minus 1 and x minus 3. Now I can test this. I want to see if I can graph a function that looks just like this. So I'm going to come over here to my calculator. I'm going to go into calculator mode, get this away from my big fat head so you can see it. And we said it was negative 3, I should probably do division, control division. Negative 3 over 4 outside. And then we said x plus 2. I'm going to use my mouse. Plus 2, parenthesis, parenthesis, x minus 1, parenthesis, parenthesis, x minus 3. And lo and behold, I look like I got almost exactly what I need here, right? I should bring that out, look like that, then look like this. But look, looks just almost exactly like this graph, right? Looks pretty good. It's a little spread out, but that's okay. So we're in good shape. That's it. That's how you do it, kids. All right, so, what are we going to do here? So I have all this data. Here. I have years and number of employees over time. Now, I don't know, just based on what I got here, if this is going to look like this, if it's going to look like this, if it's going to look like this. I don't know what it looks like until I get a picture of what it looks like. So I want to remind you of how to do this. So I'm going to pause the video for about 2 seconds so I can save time. And what I'm going to do is I'm going to type these in my calculator, if I can. And get this up. Windows 10, you got to love it. Oops, don't need Camtasia. Need my calculator. Oops, don't need that. I should be pausing this so you don't have to watch me fumble around like a crazy person. So I'm going to come over here to my table, and so I'm going to pause it for a second. I'll be right back. You won't even know this. You won't even know there's a difference. Bye. All right, I'm back. I got all this stuff typed in. So what I did was I typed all these numbers into my calculator. Oops, this should be probably 2,000. And get them up there. Well, I don't know what I'm having a hard time with that. Okay, there it is. So they're all typed in there, just like this. But I don't, like I said, I don't know what these look like. So if you remember what we did in class, I don't know what that is. I typed them all in, and so I want to get a quick sketch. I don't want you to put tick marks and axes and all that stuff. I just want a quick sketch. What is this going to look like? Is it an odd function? Is it even function? Is it going up? Is it going down? So I need to take a look to see what this is. So what I'm going to do is bring this off to the side here. I don't know why that's doing that. So I'm going to go to, remember, doc insert. So it's doc 47, doc insert data and statistics. And when you go there, it gets you all the numbers all over the place, kind of crazy. And don't forget, on the bottom is going to independent variable. In this case, it's year. Click on year. Boom, there they go. Then over here, I'm going to click on employees. Now I got a shape. It's going up, down, up. But it's almost always going up. So that is we're going to graph that over here and take a look and see what this looks like. So we're going to go, it goes up and then down. So something to that effect. So if I had to sketch the graph, it would look like, and what kind of a regression would you choose to do? Well, in this case, I would choose to do a cubic regression. Cubic regression. Well, now it might say something to the effect of, okay, if x equals 1950, write the regression equation. Oh, crap. So if x equals, now I know what it looks like. If I come over here and it says, okay, now what I'm going to do is write the regression equation for this data. So I go over here, and yeah, you're going to have to deal a little bit with some annoyingness. But so x 1950 is 0. So 0, enter. 5, enter. Oops. 10, 15, 20, 25. Because it's going up by 5 years. 30, 35, 40, 45, 50, 55, and 60. So now what I want to do is regression analysis. But I had to use the fact that it said that this was 0. And then, of course, it was going up by 5 years. I'm going to come over here. I'm going to go Menu, Stats, Stat Calculations. And I got to pick Cubic Regression. Nothing else. Cubic Regression. The independent variable is year, and the number of employees is E. So I click on that. There it is. So there's my equation in that form right there. So, again, I'll slide this over a little bit. And let's say it said rounded to the nearest thousands place. Actually, I better do 10,000s place. So rounded to the nearest 10,000s place. So A is going to equal 0.00065. B is equal to, I got to get one more, 653. B is equal to negative 0.06039 or C is equal to 1.69222743. And D is equal to 6.395604, something to that effect. So now I have to write my equation. The first thing you're going to remember to put is y equals 0.0006. I said 10,000s place, right? X cubed. We said it was a cubic function. Minus 0.0604x squared plus 1.6923x plus 6.3856. And there it is, written in my regression equation. All right, one last problem to practice with, and then I'm out of here. I think there's one. Let's take a look at this one. Domain, very simple, domain. In this case, it's negative infinity to positive infinity. Range is going to be a little bit more difficult. It's negative infinity to something. Let's pick this point, and let's say that's 14.5. So up to 14.5. Oh, including. When is f of x greater than 0? Greater than 0, we talked about it in class today. Greater than 0 is when it's above the x-axis. Well, it's above the x-axis from here. Nope, not here. So it stops here, starts here. So from -2 to 1, it's above the x-axis. Or from 3 to 5, it's or from 3 to 5, it's above the x-axis. So those are the two places. And finally, the question is, what could possibly be the degree of this function? Well, the possible degree, if we look at it, we got 1, 2, 3 turns, 3 max or mins. We got one minimum, one relative min, 2 relative maximums. So because it's got 3 terms, and you can tell it's going to be an even function because it's going down in both directions, the degree of this polynomial would probably be a 4th degree polynomial. And just for fun, the leading coefficient would be negative because it's coming down. What if I did this? Just out of curiosity. What if I drew another function in here? Let me draw another function here. I'll draw it in black. Or black. And we'll go there. And we'll go down to here. And we'll go here. And there's a line there. And down there. And up here. So let's say it's boom. Okay. Now let's just do more and more, just for fun. Let's go down. So even or odd? Well, obviously it's odd. It's going down in this direction, up in this direction. That's backward. That's odd. So it's an odd function, and it's got 1, 2, 3, 4 terms. So this would be a 5th degree polynomial. That'd be a 5th degree polynomial. And my last question is, well, I got a couple more. How many points of intersection are there? Or how many solutions are there? Well, that's where they hit. 1, 2, 3, 4. So there'd be 4 solutions for this one. Another question I might ask is, let's say I call this f of x, and let's say I call this g of x. Well, then I might say, when does f of x minus g of x equal, I don't know, 14? Well, what does that mean? We're looking for subtraction. We're looking for the difference of when they're 14 away from each other. Well, let's see. This is kind of not a good point here. That would be up 14 there and down. No, that's not too much. So this is up 10. Oh, wait, that's up 9. So maybe I should have said 13. So this goes up 9 and down 4. Up 9 and down 4. Notice there's a difference here of 13. So for what value of x would that be equal? Oh, at x equals 0. No place else do they have a difference of 14. No place else. It might be over here somewhere. They might have a difference, but I can't see it. All right, that's about it. I know it's kind of messy. I wanted to do it rough and tough. Hopefully that helps you guys out a little bit. Okay, hopefully you studied. Good luck tomorrow, kids. Bye. 20 minutes. Hopefully 20 minutes is enough to study.